So here we're going to solve a quadratic equation. It doesn't factor. You can see 4 times 11 is 44. You're not going to get factors of that to add up to 12. So we're going to use the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. A is 4, b is positive 12, c is positive 11, and here we go. So negative 12 plus or minus 12 squared is 144 minus 4 times 11 all over 2 times 4. Now you can probably see here that 144 times 16 times 11 is going to be less than 0, so we're going to get a imaginary number here. So we'll just go with it. So we have 144 minus 4 times 4 times 11. So I'm just doing this right on my calculator. I have negative 12 plus or minus the square root of negative 32 all over 2 times 4, which is 8. So that's the answers. We need to simplify this now. So the first thing we're going to do is when you have the root of a negative, it's I times the root of positive 32. Now we're going to take that 32 and we're going to simplify that because there is a perfect square that goes into 32. It's 16. 32 is 16 times 2. And the square root of 16 is 4. Okay, and now you can see there's going to be some cancellations going on here. What we're always going to do is just split up the fraction. The quadratic will always have one term in the bottom. In this case, it's 8. You can always split it up and then reduce. And it will be your final simplified 2 answers. So when you split it up here, the first fraction, 4 goes into both of those. So I have goes into 12 3 times and 8 twice. So I have negative 3 halves, plus or minus. Now you can only simplify what's not in the radical, in the root. So this 4 and this 8 can be simplified. 4 goes into both of those. So I have 1 times I root 2 over 2. So that's the final simplified answer to this. There are 2 complex numbers that have an imaginary component. So your 2 answers are negative 3 halves plus I root 2 over 2 and negative 3 halves minus I root 2 over 2. And so the only difference is plus or minus. These are called conjugate pairs. They're conjugates of each other. And complex roots of polynomials always occur in conjugate pairs just like that. So that's that.